information what we get, because everything that happens on the hardware level, on the application level, all the input, all that has to be logged and stored properly, because you never know when someday some state authority might come and say, okay, we need this kind of report, and you say, okay, how the hell will I get that data? Or is some business developer will say, okay, we have this awesome feature, idea that we can implement this product, but we need to know to have some statistics. And how do we get that? Well, we dig through the logs, we analyze them, we use tools like, there's a really cool tool like called Splunk, or just statistics, awk, and well, you dig and search for stuff. So that's an important part of our process. And yeah, domain-specific languages, that's a really cool thing. Because sometimes we got problems that are not, well, Erlang is good, but we need something else. We need something on a different level, on a higher level. So we write domain-specific languages that would solve, namely, that problem. So, for example, if for the problem of deciding, do we allow the shop or the purchase or not, we have a language that looks just like the wiki syntax, and it's really easy to be changed for other like non-developers. So this is an example where this can be helpful. Okay, I see like people start yawning, so I should move on. Yes, and a different thing that I was just not thinking about this when I was studying. I was thinking like, okay, I'll hack on my own little system, and oh, that's cool, like it does stuff, and I can always go in and change it. But when working in a large organization, there are like requests coming in, and you have to change all that manually. So it's just better to empower the users. So give as much responsibility to the people that will use that. If you work on something, if you, like second year students are doing that project with the helicopter, cool. If imagine that you would just sell it to me, and I have no idea what's inside, how it works. Just give me as much possibility to tweak it, to change the way it flies, like backwards or something, as possible. Make it easy for people to change it, to adapt it, because they like it. They like to be able to adapt things. And most oftentimes, they will not be developers. They will not, they're afraid of the code. So let them change your stuff. All right. So, in essence, program. This is like, as an advice, what you can do here. Program, write code, write a lot of code. That's really important. Yes, pay extreme attention to the soft part of IT, but do program, do write code. That's, yeah, practice makes perfect. Teamwork, extremely important. There are a lot of, you might think there are a lot of morons, but you never know when you're the moron in the team. So it's better to just not think of like that, of people like that. Everybody has different views, so adapt to those views. Communicate, that's really important. All of this builds on communication. If there's bad communication, if people don't listen to each other, if they don't understand what the other guy from the other department is saying, it's going to help. Yeah, do learn all the time. Whenever you see a course or something happening, or you can join the local club or something. If you're out of the university, you'll be in a different city, and you like something, you like I don't know, some special framework or something, do join. Most probably there's a club or some people meeting once a month discussing that. Join that. You have to learn new things, otherwise you're dead. Algorithm complexity. This is really important. Like, you have to know how to apply it. Writing code is good, but it has to be meaningful. It has to be well implemented. And you have to know the trade-offs. Should we make it like, should it use more CPU or RAM, or like, you always have the trade-offs. Think about that. Think how to, like, think, well, in university, think about algorithms, learn about algorithms, read that, even if you don't have a course on that. Find it in Chalmers somewhere and read about it. And yeah, creative thinking. Again, software engineering and management, this program is really good at this. Because of the unorthodox way of teaching, because like sitting like this in groups, I think it gave me the freedom to think in a different way, in a more open way. It's not like streamlined in a classroom. Okay, you have a lecture, everybody sits there, then you go home, do these exercises from the book, or this assignment, and that's it. Here we were able to like, well, sit like this and implement our own stuff. And yeah, tools. As I said, do challenge yourself on the tools. At Klarna, as I said, they forced me to use Emacs. I was really mad in the beginning, but now it's really cool. Version control systems, we use Git. And okay, how many of you know what Git is? Cool! I guess the first year students don't. They look confused, right? Yeah. Yeah. But it won't be long until you do that. Try out, during your education, try out in your projects different version control tools, because, well, you never know what's best. You have to try it. Yeah, because since it's a large system, a large code base, we have to debug often, and you better learn how to use those tools. Don't just like, I remember, I think the first encounter with debuggers was during Henrik's course actually. What? I can just like write a couple of I/O formats, print out stuff, and it will show me where it came and where it stopped and what part doesn't work. No, that's a really bad idea. Debuggers, tracers are really important. You have to know where the action is, what's happening, and printing out stuff. No, don't do that. And yeah, since we have a lot of logs, we extensively use log analyzers. Do learn, try like awk. You have to have that in your toolbox. That's a really handy language. So and it will help you later on. We even sometimes use network traffic analyzers if something goes really like there's some really elusive bug and we don't know what's happening and it's over a network, then it's good to examine stuff on the packet level and see what the heck is happening there, and then you actually find it out. So you might not go as deep right now, but well, do try and find out what's happening. Okay, you have the API of Java, right? If we say that here on the highest level, do try and find out how the whole thing works. The virtual machine, garbage collector, hardware, how it works, what happens there, the network, how it works, all the way. Do learn how a computer is implemented. I don't know if the program changed. We didn't really have that in our program, but this is really valuable knowledge. Learn that. Try to just let your curiosity drive you. You have to learn all the way down to ones and zeros how it's implemented. You don't have to know it like extremely well. You don't have to re-implement the computer. It would be great, but it's not that difficult. It's not as difficult as you would imagine, but that really helps to know what things might go wrong. So don't look only on this higher level. This is good, but if you want to work, if you want to have extensive knowledge and you want to know what you're talking about, go all the way down. It helps. Yeah, and well, sometimes we have to write our own tools, and that's cool actually. Yeah, I had the comment there like use